pretty much, yeah. Oh, sorry. If you weren't here, tell me again. All right.
In that example on the board right there before you erase it, is that a P or?
That's a P. See how the lines on that side?
Yes, it was like a hybrid of letters.
Oh. There you go. Now it's awesome. So the remarkably truncated lecture on this is, if I draw a probability distribution, whatever it looks like, it could look like that. Wow, wow. So this would be the mode. Is that cool? Mm-hmm. It's the highest one, so that's the one that occurs the most. So most of the data seems to be in here. There's little bumps in other places too, right? So if I drew this correctly, the area of the whole thing should be 1, because that relates to the probabilities all add up to be 1. So this is a probability distribution, right? For a discrete data. And all these probabilities have to add to 1. So how do I do continuous data? Continuous data I couldn't do a table for, because I'd have to include every number, and I wouldn't get very far away from 0. 0.0000000000000, you know, and in the infinite place 1. 0.00. Okay, screw that. I'm just going to draw it. So this is a probability distribution, just like the tables are probability distribution. This is just continuous data. So I want a visual, right? So the total area would be 1. And then if I want to find the probability between two things, I'd have to have a way to figure out that area. So some problems will use what's called a uniform distribution. What shape does that take on? Uniform distribution. Rectangle. And finding the area of rectangles is easy. Easy, right? So a very quick example. If this was ages of kids in some youth karate camp, and it's uniformly distributed from 7-year-olds up to 12-year-olds. Are you guys still with me? Mm-hmm. What's the what would the height have to be in order to make this that we just said true?
1/5.
Have to be 1/5. I love it. Because how wide is this? 5. 5 times what is 1? 5 times 1/5. The multiplicative inverse, or reciprocal. And then if I ask you, what's probably then that a kid is aged 8 up to 10, you just have to find the associated area. That's it, right? That's almost too good to believe, but let that make just total sense. Please. So if this is my A to B and this is C to D, which one has more area in it, A to B or C to D? I say, see, that's where more of it is, right? So there's a higher chance I would get something in C to D. So areas are directly related to probabilities. When I draw it, so it has a total area of 1. Let me let all that sink in. So please let these problems be like, oh, thank the gods. Right? So this would be what? What's the area of that rectangle? How wide is it? 2 times how tall is it? 1/5. So it's got a probability of 2/5. There's a 2/5 chance I'll get a kid between 8 and 10. So just go in and grab one. How old are you? 8. Okay. Then he kicks my ass because he knows crap. Let me go. I don't know you. All right. Thankfully, it's not interesting. So now, the transition from this, on the back side of that, this side of it is my trying to bridge the gap between stuff we know and stuff we don't. So if it's a shape that I can do the area of easily, great. If it's a shape I can't, we have to rely on calculus. And since a lot of us don't know calculus, we're just going to use other people's work. We made all the calculus kids in the world do this for us, and we're like, all right, good job. We're going to use this shit. If you don't know calculus, that means you can't do anything that's not going by that chart. So if you do know calculus, you can do a lot more. Yes?
Between the 8 and the 10, is that a less than?
Oh, yeah. I kind of sort of half asked that. X between 8 and 10. Now let me talk about something real quick. I'm glad you said that, because what's the probability that X equals 11, let's say? It's probably X equals 11. How wide is that I just drew? Is it 1 wide? That would be like 10 to 11. Wouldn't that be 1? How wide is a line? 0. 0 wide. So the probability of any equals is going to be 0. That's freaky. So if something is truly uniformly distributed, how many total things are in here? How many total numbers are in here? Oh, this would be neat. Not 5, not 6. It's not anywhere near enough. Infinitely many. Couldn't you be 7.013469247247239725 years old? Yes. Or 7.0147 7 years old. So the probability of any individual thing is 0. Because how many of them are there? Infinitely many. Right. All right, that's there's going to be questions where they ask you what's probably X equals 11. Well, the area is 0, so you're done. So you don't have to kind of freak yourself out thinking about this. To be honest, though, just in case you're curious, so we're going to say that's 0. So Troy, you can just cover your ears. You should look up the idea of iota if you're iota. Anybody ever heard of iota? Yeah. You have an iota chance. You have iota basically means it's related to, and a lot of math people don't agree, and I don't give a shit. Iota is like like what's infinity? What is infinity? Oh.
It's infinite. I don't know.
What's infinity? Is it the largest number? Does that make sense to say that?
No.
No, because if you think you got it, you add 1 to it. Or you double it, and you ain't got it. So infinity is a process, right?
Yes.
So iota is the reverse process. So infinity would be like this: 10, 100, 1,000, continue on forever. That's one way to represent infinity. So iota is 1 over 10, 1 over 100, 1 over 1,000. What's happening?
It's getting smaller.
Smaller, smaller, smaller. Does that ever get to 0?
No.
Shit, no, because the top is always 1. So iota is the opposite idea of infinity. That's all. I'm sorry if I hurt your brain. Oh.
So it's just smallest.
One way to say it.
The smallest.
One way to say it that really irks people is it's the smallest positive number. That makes as much sense as saying that infinity is the largest positive number.
I don't give an iota. I don't.
Yes.
Right.
Right.
I don't.
Well, grammatically that's not quite.
No, that
Yeah. So I don't give an iota means you don't even give like 1 over infinity.
Right.
You give 0.
Right.
I was going to say that.
Yeah, there you go. Now, I know I just talked about that for at least a minute, and this iota shit's not going to show up in any test or quiz in here. This is just
Knowledge.
to see if anybody out there is interested, because the first time I learned about this, I was like, whoa, shit. Okay, cool, let me see it. So I don't know if anybody out there's like me at all.
You're not alone. It's okay.
Really? I'm just saying that to make me feel better. Okay. So, once we made that bridge to understand the areas tell me probabilities, if I have a normal... Yes, sir?
What's the symbol for iota?
Oh, well, I'm going to let you guys... I was about to say,
It's a Greek letter.
somebody bring that to me tomorrow. Huh? Oh, good try. This is just, you're interested. So we'll see if anybody...
It's
I know what it is. It's a neat Greek... iota is actually a Greek letter.
yeah.
So it's like epsilon and sigma. It's a Greek letter. So you can look it up pretty easy. Right? No, that's phi. Phi or phi. Total sum. Huh? Not really. No. Well, I mean, that could be.
That's the
could
Greek
be it.
alphabet.
Yeah. I wouldn't say it's like a J, but.
Yeah.
Oh, well, it's like an I without. Yeah. I mean, that could have been a guess somebody would make. Okay. So then we moved into, if I have a normal curve, is it easy to find sub areas of this? So like, what's the area of that? Is that a shape that you learned in your basic geometry class? Shit, no, right? You guys understand what I'm saying? That's why we need the chart to help us. That's the reason the chart exists, so that we don't actually have to do the calculus, so that you don't have to take stats after calculus, right? Okay, so how does the chart work? Let's remember how to do that. So if I want to know, so where's 0 go in this chart? Because this is a chart of what? What is this a chart of? Z-scores to begin with. If it's not Z-scores, we make them Z-scores, and we have a formula to do that. So here's where 0 is. So just to kind of give these some numbers, maybe this is negative 2.7, let's say it's 2.71, and negative 2.32. Sure. So just try to figure out the area in between those two. So what the Z-score chart does is whatever Z-score you look up, it tells you the total area below it. Theoretically, that tail goes forever. Right? Oh man, can somebody play with the light station? John, like, just say John. Say something. Okay, so if I look up, so the way this chart works, that's the second decimal place up here at the top. So if I want to look up Z of negative 2.32, for example, negative 2.3012. So you get 0.0102. So that's going to be the area. Oh well. You know, you can look at yesterday's video. Whoever's out there in the world. So where does that go in the picture?
Up at the top.
True, but be more precise. Good? That way from where? Negative 2.32, yeah. That's the one we just looked up. I immediately put below it 0.0102, right? Now, is that going to be the answer?
No.
Is that too much or too little?
Too much.
Too much. So I want to figure out what's below this so I can subtract it off. Okay, I like it. So if the question was probability Z less than negative 2.32, the answer would be 0.0102, right? But the actual question I have up here is, what's the probability that Z is between 271 and negative 232? So what do you get when you look up negative 271? Is it going to be bigger or smaller than that? Some of you guys have already looked it up, but it's smaller. It's going to have less area out here, of course. What do you get? Sorry. 0034. So how do you find the area in here? Subtract those two. I love it. So this will be 0.0102 minus 0.0034, which is 0.0068. I like it. 0068. Yes?
Do we have the answer in percentage?
No. You see how I circle that? But you could, if you want to take one more, so you can make it 0.68% if you want to. Yeah. Cool. But see, this is why I was trying to get you ready for 4, because this gives everything in 4 places. All right. Now, just to show you an example where you don't know the z-scores, and let's say I have a mean of 311.9 and a standard deviation of, what you got, Jeff? I don't know, 37.2. Now, I haven't made this really a big point yet, but if you look at the top of the z-score chart, what kind of picture is there? Yes. And the reason that this chart could exist where I know exactly the percentages is because it only works if the shape is a bell curve shape. And actually, to be more precise, it must be a normal distribution exactly in order for these probabilities to be perfect. So can I use this if I don't have a normal distribution? Hell no. So a big part of statistics is what has to happen so that I know something is normal, or what I call normal enough, to use the chart. Does that make sense? If I know something's normal enough, this has got answers all over the damn thing. If I don't, I can't use all that shit. I got to do some weird shit that would be in Stats 2 if we offered a Stats 2, so I'm sorry. Right? So right here, before we learn some other shit, I just got to tell you it's normal. I got to tell you that it's normal, or else you can't do anything. So if I ask you, okay, given a distribution that looks like this, I know it's normal, so I can draw it. What goes right in the middle?
0.
Careful. That was because these are z-scores, right?
311.
What always goes in the middle, the mean. If it's z-scores, the mean becomes 0. So if it's z-scores, the middle is 0. I totally agree with you. This is not z-scores yet. I haven't converted them yet. Right? Gotta go knock on these guys' door and try to make them join up. 311.9. Now what data value am I interested in? I haven't told you yet. So what have I asked? What's the probability that I get a raw score? So when you hear somebody say raw score, that just means it hasn't been changed into a z-score yet. Let's make this into a, I don't know. What would have an average of that? That's too high for a bowling average. So I don't know. This would be the miles driven in a week by somebody who drives a lot. Okay. So this guy averages this many miles, this standard deviation. Okay, cool. I like it. So, what's the probability that this guy drives less than 300 miles? That would be the question. So I don't put a Z there yet because it's not a Z-score. Z-score, what units do Z-scores have?
Standard deviation.
Standard deviation. It's a number of standard deviation. This has units of miles. So it's not a Z-score yet. It's what I call a raw score. I haven't processed it yet. I'm making too big of a deal out of this because it's nothing too bad. Where's 300 go? Yeah, please, dear God. Sometimes they don't realize these numbers have to be numbers, you know. They just put 300 wherever. 300's got to be here somewhere. You don't have to be perfect. This is just a quick visual to help you figure out if your answer makes sense, for one thing. So, should my answer be more or less than 50%? Less. So for one thing, if you draw this correctly, you know an estimate of what to expect, right? Okay, maybe. So can I use this chart in general for a problem? Yes, it's normal. But can I use this chart with the numbers I know at the moment? No. So how do I convert that into a z-score? Yes, sir. Yeah, how do I convert that into a z-score? I like it. Oh, shit. Right? Remember that formula? It's finally coming back. So then Z equals 300 minus 311.9 divided by 37.2. I'm converting it into a z-score. Why am I doing that? So I can actually use the chart that has all the answers sitting there. Do you see why it's really important you get everything in the right order there? Because I know the z-score should come out negative or positive.
Negative.
It's got to come out negative. And the negative side has all the small amounts of area because they know they're below the mean. They know there's a small area below it. So if you get a positive z-score, you're going to get the wrong answer. So if you just turn this around, you're screwed. Yeah. Okay, I can do that. So what's that going to be? Like 0.3? 3.2. Always, of course, rounded to two places. Why? Because the chart only goes out to two places.
Isn't it negative?
Negative. I like it. All right. So now it's just like this problem. Just like it. One step, and it's this problem here. And now I made it to a z-score. I can look it up. So what does this become as a z-score? This here? 0. And what does this become? Negative 0.32. So I always do this for myself. When I took stats about 80,000 years ago, our teacher made us draw a separate picture. That's dumb. It's going to be the same picture. Sorry, Mr. Pearson, wherever you are. You're fine. But it is kind of dumb. I just put underneath it in parentheses the associated z-score. Why do I do that? Because I might have multiple scores and I want to keep track of who's what. So when I look it up, I know what to put it below. So what do you get when you look up negative 0.32?
0.3745.
Negative 0.32.
3745.
Yeah, 0.3745. One easy mistake to make is look at negative 3.2. No. It's negative 0.32. Is everybody cool with that? 0.3745. Is that the answer?
No.
Aw.
Yeah.
Of course it is, yes. It matches up with the area I shaded. I know I'm done. If I had shaded there, I would have had to do 1 minus. If the question would have been greater than, I would have needed this side. I would have done 1 minus this to get the other side. Oh. Okay. So now, do this. Right? Do it. It's on the back of this. So do the back of that. Some of you guys have done some of it. Try to group up with other people if you want to.